Hi dear students, welcome back to the YouTube channel. Here let us go with the first chapter of class 9 mathematics number systems. Towards the end of the chapter, you will learn about rational numbers, irrational numbers, then real number and their decimal expansions, operations on real numbers and laws of exponents for real numbers. Okay students, let us get into the chapter. In our previous classes, we have already studied about number line. What is a number line? A line in which numbers are being represented, right? We have already studied about real numbers. And the representation of real numbers on a number line, we have studied in our 8th class. And today in this section, we are again going to recollect some of the things which we have already studied, and we are going to understand a little bit much more deeper about the number system. If you are considering a number line, you know that at the centermost of the number line lies 0. Towards the right side, if you're going towards the right side of the number line, you can see the positive numbers are included. And whereas if you're going from 0 to the left side, negative numbers are given there. So if you're going continuously to the right side, you can see the numbers, the value of the numbers gets increasing. 2 is greater than 1, 3 is greater than 2. Like that it keeps on increasing. Whereas if you're going towards the left hand side of a number line, the value of the number gets decreasing rapidly. Now let us study some category of number systems. Number 1, natural numbers. Natural numbers is denoted by capital letter N. What are natural numbers? In simple words, we can say counting numbers are what we call the natural numbers. See, if anybody told you to count, come on, count how many students are there in your class. From which number will you start? Will you start it from 0, 1, 2, 3 like that? No. If I'm asking you how many books are there inside your bag, how will you start your count? You will start from 1 itself, right? 1, 2, 3, 4. That's the way how you normally used to count. So in simple words, we can say this is what we call natural numbers or counting numbers, means it starts from 1. So we can say natural numbers starts from 1, or the least natural number is 1. From 1 starts the natural number 1, 2, 3, 4, 5, 6 and go on like that. So this category of number is what we call natural numbers. It is represented by the letter capital letter N. And if 0 is added to this natural number, what if 0 is added to this natural number? Right now I told you what is natural numbers. From 1, 2, 3, 4 means the counting numbers are what we call natural numbers. Along with that one, if you are adding 0 also, 0, 1, 2, 3, 4, 5, then it becomes a group of numbers which is called the whole numbers. You can see here the whole numbers. It is denoted by the letter W. Okay. So whole numbers is the collection of numbers from 0, 1, 2 like that. Means it's a collection of numbers which includes all the natural numbers along with 0. Means 0 is included along with the natural numbers. Altogether this set is what we call the whole numbers. Is that clear? And now initially I told you about negative numbers, right? When I was talking about real number line, I told you about negative numbers. So this positive numbers, negative numbers, all these things, 0, all these things together we can say integers. What are integers? The collection of positive numbers and the collection of negative numbers along with 0 is what we called, because 0 is not a positive number, it's not also even a negative number. It cannot be a positive, we cannot represent it as a positive number, neither it can be represented as a negative number. That's why it's a non-positive, non-negative number, 0. So that's why I told you all the positive numbers and all the negative numbers along with 0, it comes together under the set of integers, and integers is represented by the letter Z. Now you may be a little bit confused because whole number was denoted by W, right? Natural numbers by N. Then why didn't we took I as integers? I will tell you. Z means actually it's a German term. It's a German term. Zahlen, Z-H-L-E-N, Zahlen. And this Zahlen means to count. That's the meaning of that one. That's why they are denoting the integers by using the letter Z. Clear? Next category, rational numbers. What are rational numbers? Rational numbers are the numbers which can be represented in the form p by q, where p and q are integers, and especially q should not be equal to 0. It's very clear, q should not be equal to 0. That means in simple words we can say the denominator should not be equal to 0. That's all, keep this in your mind. The denominator should be not equal to 0. Why? What happens if the denominator becomes 0? Actually, see, what does the denominator means? What does the denominator means? It means when you are considering a fraction, just imagine that of your marks which you obtained in your half-yearly examinations. Out of 100, if you got 90, that means out of 100, you are getting 90. It's possible, right? Out of 100, 90 is possible. What about out of 0, you got 10 marks? Is it possible? Because there was not even an exam, then also you got 10 marks. Is it possible? No, it's not possible. It's impossible. That means multiplication by 0 is not there. It means the multiplication table of 0 is not there. That's why we cannot divide any number by 0. That's why it is clearly said that q should not be equal to, even though we are saying that q not equal to 0, that should come into your mind that the denominator part should not be equal to 0. And one more thing is very important. This p and q should be coprimes. What does it mean by coprimes? Coprimes means these p and q, they should have only one factor, and that should be 1 itself. Means they are having only a single common factor, that is 1. In simple language we can say like this: it should not be cut on the numerator and the denominator by any other numbers. For example, 2 by 4, you can cut 2 and 4 by using the table of 2, right? 1 times, 2 times, like that you can cut. So normally we can say 2 by 4 is not a rational number. Even though it is considered as a rational number, it's not of the general form. The general form of a rational number, the general form of a rational number means it should be of the simplest form. It should be of the simplest form. When it comes to the simplest form, they should be coprimes. Coprimes doesn't mean that these two numbers should be prime numbers. It doesn't mean like that. For example, 25 divided by 16 or 16 divided by 25. Just imagine that one. 16 is a composite number. 25 is another composite number. But 16 and 25, they are not having any common factors other than 1. So we can say 16 by 25, it's a perfect rational number. I hope you understood, right? This is what we categorize rational numbers. Now there is another set of numbers which is what we call irrational numbers. What are irrational numbers? Any number which cannot be written in the form p by q, where p and q are integers and q not equal to 0, and p and q should be coprimes. Same like that. Just opposite of rational numbers. Means if you cannot write a number by the form p by q, then that is what we call irrational numbers. But there is much more explanation for this one when we are coming to the decimal expansion of fractions. There I will have to give more clarification about irrational number. But for right now, just imagine like this: if you are considering a number which is under a root, which is written under a root, and you cannot take the root of that number. For example, if it is not a perfect square number. Okay, for example, root 1, it is 1, root of 4, it is 2, root of 9, it is 3, square root of 16, it is 4, square root of 25, it is 5. That means those numbers are what we called perfect square numbers, because we can take the root of that number, we can evaluate the root of that number. If you are just neglecting these numbers, avoiding these numbers, rest of all the numbers which comes under the root is what we call irrational numbers. That is category number 1. Means the number which are seen below the root signal. There is a symbol of root, and inside that one, if a number is there, and if that number is not a perfect square, then definitely you can say that is an irrational number. This is category number 1. Second one, if you are taking a decimal expansion of a fraction, 0.10, 11, 0, 0, 0, 11, 0, 0, 0, 0, 11, 0, 0, 0, 0, 0, 0, 11, 0, 0, like that. Means it's a non-terminating, but at the same time it is not repeating also. It is non-terminating and non-repeating. So non-terminating, non-repeating fractions, non-terminating, non-repeating decimal expansions is also what we call irrational number. When we are coming to that particular topic, I will explain much more. There I think you will get it into your mind very fast. Okay. How about learning how to represent this irrational number on a number line? Because last year in 8th class we studied what is irrational numbers, and this year we are going to study how to represent them on a number line. Next year, when you're coming to your 10th class, there you will study how to prove that a particular given number is irrational. Okay, so now let us go to this one. First of all, let us represent a root 2 on a number line. Root 2 is regarded as an irrational number, and it was proved by Pythagoras, and later on plenty of mathematicians, they proved that root 3 is also irrational, root 5 is also irrational, root 6, root 7, root 8, root 10, root 11, root 12, root 13, root 14, root 15. Like this, they started proving plenty of irrational numbers. So initially Pythagoras gave the first step to prove the irrationality of numbers. So now let us represent them on a number line. Okay, now here let us consider a square OABC, a square, a unit square. So it's of unit length, that's why I told unit square means every side is of 1 unit length. Now OABC, and if you are drawing a line from O to B, that means that will be a diagonal of that square, right? OB. Now what about the length of OB? By using Pythagoras theorem, we can right now you can see there is OAB. This OAB is a right angled triangle, because I told you it is a square, so definitely it is a right angled triangle. So OAB is a right angled triangle. Now tell me, what will be the length of OB? OB will be equal to root of OA square plus AB square. That means that will be equal to root of 1 square plus 1 square. That means that is equal to root of 1 plus 1, and that is equal to root 2. That means OB is the total length, that is root 2. Now let us take this square and let us drop this on the top of the number line. And when you are keeping this on the number line, forget not, the vertex of the square O should come exactly on the 0 of the number line. Okay. Now if you are placing this one, right now you can see the figure here. So here you can see OABC. We already showed that OB is equal to root 2. Now how can we mark this OB? That means this root 2 on the number line. Take a compass and take the radius OB in your compass, and taking the center as O, draw an arc from B so that it meets the number line at P. Now we can say this OP is what we call root 2. Is that clear? This is how you can draw root 2 on a number line. You can represent root 2 on a number line. So like this, actually it's so easy to represent any rational numbers or any irrational numbers on a given number line. So what does this number line means? Means it's a collection of all rational and irrational numbers. If you are collecting all the rational numbers and if you are collecting all the irrational numbers together, that is what we call the real number system. That's why a number line is also called a real number line. It's also called a real number line. And forget not, if you are taking any point on a number line, and that point will be a unique point, means that point will be represented by a particular number. For example, if you are taking a point on the number line, and if you are saying that it is, for example, here we took as root 2, right? There will be not even a single another root 2 on that number line. There will be only a single root 2, and that is what we have proved right now. There is no other root 2 in that number line. Means if you are taking a point on a number line, it will be a unique point. It represents only a single point. Okay, that's very important. It's a very great theory also. Okay, now let us get into the exercise. Exercise 1.1, question number 1. So see here, state whether the following are true or false and justify your answer. Here there are some statements given before you. We have to analyze them and we have to say whether it is true or false, and we have to justify our answer. First question. Every irrational number is a real number. Is it? Every irrational number. Just imagine of irrational numbers. Okay. Every irrational number is a real number. It means it comes inside a real number category. Is it? Yes. True. Why? Right now I told you, if you are taking a real number, all irrational and rational number comes inside the real numbers itself, right? All irrational and rational comes. So definitely we can say every irrational number is a real number itself. Even though it is irrational number or it may be a rational number, it comes inside the category of real numbers, right? That's it. Question number 2. Every point on the number line, if you're taking any point on the number line, it is of the form root m, where m is a natural number. Means if you're taking any point on the number line, just imagine a number line in your mind. Take a point and that point can be represented as a root m, and m is a natural number, means m should be a natural number itself. Is it? No. Why? Because in a number line, you know, negative numbers are also there. It's negative numbers are not rational number. Negative numbers are not natural numbers, right? So that is false. That statement is false. Third statement. Every real number is an irrational number. Every real number, whatever real number you are taking, it should be irrational. That means in a number line, there is only irrational number. Is it true? Very simply, we can say it is false, right? So we have to justify. Let us take a number 3. What about 3? 3 is a number which is on the real number line, right? It's a real number. What about 3? Is it a irrational number? No, it's a rational number. Why it became a rational number? Because we can write 3 as 3 by 1, right? Any number can be written by the form p by q is a rational number. So 3 you can represent it as 3 by 1. So there it is. So definitely we can say this statement is also false. Second question, are the square roots of all positive integers irrational? Are the square roots of all positive integers irrational? If you are taking the square root of all positive integers, whatever positive integers are there, if you are taking the square root of that one, they should be irrational. Is it like that? Normally, I told you, normally when you are considering an irrational number, that comes into your mind, means whenever you are seeing a root, that there is a probability that it becomes irrational. But under one case, I told you, if it is a perfect square number, it never becomes a irrational number. If it is not a perfect square number, definitely it will become a irrational number, right? And now our question is, are the square root of all positive integers, means whatever positive integers you are taking, every positive integers, if you are taking the root of every positive integers, is it an irrational? No, it isn't. How can we prove? Just take one, root 16. What about root 16? The root of 16, square root of 16 is 4, right? 4 is not irrational. 4 is a rational number. So we can say it's false. This statement is also false. Coming to the final question of exercise number 1.1, question number 3. Show that how root 5 can be represented on a number line. First of all, I told you how to represent root 2 on a number line. Now let us go to root 5. Whenever we are doing this root 2, root 3, root 4, root 5 or anything, forget not, every time we will use the Pythagoras theorem. That means hypotenuse square is equal to base square plus altitude square. Every time we are going to use that theorem to find any irrational number so that we can represent them on a number line. Okay, here let us do this one. So again, here you can see there is a number line, and take 2 units as its base, and from 2 units base just mark that point as A, and from A take 1 unit perpendicular height, and mark that point as B. Now join B and O. Now you can say OAB. OAB is a right angled triangle, right? So inside a right angled triangle, if you want to find the length of OB, how you will find the length of OB? Here you know this OB is the hypotenuse of the right angled triangle. Again we have to use the Pythagoras theorem. Now how to find the length of OB? Being hypotenuse, we will take it as root of OA square plus AB square, right? That's equal to root of, what is OA? It is 2 units, right? 2 square plus 1 square. 2 square is 4. 1 square is 1, 4 plus 1 is 5, that means root 5. That means you got very clearly that OB is root 5. Now take a compass, measure OB as a radius. Take OB as your radius in your compass, and fixing O as the center, draw an arc from B so that that arc will touch the number line, and where the arc intersects the number line, that is your root 5. So this is how we have to represent, we can represent root 5 on a real number line. I hope you understand this class. Thanks for watching the video.